Welcome everyone to the HackUCF General Body meeting today. I'm Michael Teresi, the current president. So let's get started. First things first, our sign-in form is now open for the meeting. This is just the easiest way we kind of have to take attendance given this whole remote format. It's just a Google form that takes your name and your night's email. It's pretty simple, and you can do that the entirety of this meeting, and it'll be open until then. So. We also have a mailing list, a shop, a Twitter. We go through this. You can follow us on many platforms. Our most popular is our Discord and our most active. That's where all of our members are. We have some channels you can ask questions, interact with other members, all cool stuff like that. We have a virtual Cyberlab where we hang out sometimes after the meetings. Great stuff happens there. So today's topics, we're going to go over announcements for this week. We will then have current events with Tupperware, and then we will move on to our secretary election. We'll talk about that later. And then the main talk today is going to be hardware hacking made easy with Nothingness, one of our alumni. And then we're going to go ahead and close the meeting out. So on to the announcements. We have an operations meeting every Monday at 7:30 p.m. If you'd like to help run the club or give us ideas for general body meetings or help run workshops and give stuff like that, anyone's welcome to join at Mondays at 7:30. It will be on Zoom, and the link will be in web courses, in the calendar, and also pushed to the Discord when that day comes around. And of course, they're open to anyone. Something happening right now is the Lockheed Martin Grand Cyber Challenge. This is kind of their CTF that's happening for about a week or 10 days-ish. It's going on from the 9th to the 18th. And the restriction around that is that you must be a college or university student to participate, which most of us usually are. And that's the link to register for that event. And as you can see, if you do win, first place gets an iPad, second place gets some AirPods, and third place gets Bluetooth speakers. They describe it over the course of the week. Participants will complete to solve a variety of cybersecurity challenges that range from incident response to web application security. Questions prompted for a free response, so like submit an IP address or identify the attacker in this game. And during the challenge, there'll be several virtual networking sessions, kind of like a virtual networking event with people from Lockheed Martin. So you can get to network with those people there and hopefully pass some resumes around. This is their schedule. It did start today at 3 p.m., so just about 2.5 hours ago, but it is open still. October 13th is that virtual networking event where you can meet other participants and Lockheed Martin employees to kind of get your name out there and really network with people in the industry, which is a great opportunity to have. And it does end the October 18th at 5 p.m. And then they will announce the winners the following day on the 19th at 4 to 5. And it looks like another networking session as well. So additionally, we also have Cyber Carnival games. Not quite a CTF, but kind of little carnival games that they call it, which are more designed to be fun and educational. And it's an event focused around Cybersecurity Awareness Month. That's the link for what that's about. And then the last link is the actual Cyber Carnival Games registration link. We can find information all about that. You can register for different events happening up until October 29th. So it's not a continuous event, an ongoing event, but it's a series of individual events you register for between now and the end of the month. So you can pick different events that you want to participate in and just play those games that they have. Coming up a little soon is the very large and free for students online conference that we have, which is B-Sides Orlando. It is on November 6th and the 7th, and registration is open now, and you're able to get your tickets today. We also have many of our own members and alumni who present there from time to time, and there will be some there this year. And bsidesorlando.org is the website you can get for all the information around that B-Sides Orlando. Along with B-Sides Orlando, we also have Sunshine CTF, which is our CTF event for B-Sides Orlando. We help kind of participate that and organize that, and we get thousands of players worldwide. And of course, there's the URL for information about that. We are still accepting challenges for this event. So if you'd like to participate in creating a challenge for Sunshine CTF, in the Discord, you can reach out to Hilly Thumper or Kevin Colley or Kay Colley, and you can reach out to them and they'll get you hooked up with how to make CTF challenges and what kind of things they'd be looking for. And if you'd like to be a CTF creator, this is a great time to kind of get your foot in the water there. So last thing is we will be having a Git workshop on Saturday tomorrow. That's going to be with Tupperware, Saturday at noon. Git introduction workshop. If you're not familiar already, Git is kind of like that. It's that source control tool that you can use to push code to GitHub and keep changes or keep track of changes as they occur. So you can keep a log of when code was changed and when. It's a very useful tool that's used a lot in the industry, and it'll be very helpful for you to know. We don't cover it a lot in the classes that I've seen here at UCF, but it's very useful to know, and it's great for those senior design projects and stuff like that that you have to work on in your classes. And of course, we have our virtual Cyberlab, which is our voice channel in the Discord server where we hang out, play games, ask questions, and just generally socialize. It's open 24/7, and you're able to jump in during the week after the meeting. Normally after the meeting, we do have people who like to stream games there. We do now have a Minecraft server that you can access, minecraft.iqcf.org. You can play that in there as well, and it's going to hang out with everyone. So with that, let's move on to the secretary elections. So in just a moment, once the candidate gets to speak and introduce themselves, I will drop a link to the Night Connect election in the active student members channel in Discord. It will stay open until 6:30, and we're going to then announce the results of that at the end of the meeting. So you have about an hour to vote and listen to what has to be said and stuff like that. You do have to be a member in Night Connect to have that link. Most of you should already have requested access, and if you pay dues, we will then have given you access to that. So I'm going to hand it off to Jeffrey, and he can make his short presentation and introduce himself before we go to vote.
Thank you. So hi, I'm Jeffrey. I'm a computer science sophomore here at UCF. I've been with the club for about over a year now. So why vote for me for secretary? One, I'm organized. I'm the kind of person who schedules almost everything in this day, so I can ensure that what people entrust me to do gets done promptly. This is especially true with newsletters, which is one of the secretary's responsibilities. I'm also a pretty good note taker. I'm also, as secretary, in charge of taking minutes for all the meetings. So I want to make those notes as clean yet comprehensive as I possibly can. But also, I really love this club. I care deeply about it, and I try to be as active as possible. I started getting involved with ops late last year, early this year, and whenever I have an opportunity to, I try to lend my opinion. I'm also quite active in the management of Sunshine CTF, where I'm designing the theme there. So if you want, feel free to vote for me. It's an important role, but I hope you do consider me. Back to you, Michael.
All right, thank you. And I just posted the link in Discord for you to vote. Anyone in the meeting, you're welcome to. Let me just make that context. Sorry about that. Cool. All right, that will be open until 6:30, and we'll announce the results after the main talk today. So you can find that in Discord. It was pinged, so you should be able to find that. If not, reach us out in Discord, and we'll get that sorted out. Now we'll take it on to current events with Tupperware. So take it away. If he can. Be in the call with us. Addison, do you see him?
Hello?
Yeah. I don't see him, so I guess I'll go ahead and do it myself. All right. So first thing is Azure again. It went down last week, it seems. It was not a hack. This was reported by downdetector.com, which is a very useful tool that I use all the time. If you're unable to reach a website, or you think something's going on where you can't access something, you can go there and give it a service. They also have things for video games, so you can find out if it's just you having the issue, or if it's an issue that many people are having, and you know it's not just you, it's shared by other people. My previous working experience with Azure, It does go down often, so this does not come as a big surprise to me. I know one time I had all of the VMs in Azure go down for just like no apparent reason. I logged into the Azure console and there was just nothing there. That's the good time to take my lunch break, and I did. So Azure, what a wonderful place it is. Next thing, we have Python 3.9. It's a major release for Python. It seems there was an issue 37228, and it basically allowed for incoming package to choose random UDP port. Fortunately, I can't give much more information about that one, but it doesn't sound good. Let's see. Yeah, it's kind of what it is. Software AG, kind of an example of why cybersecurity is important. They were hit by ransomware. I believe it's I actually am not sure. It appears ransomware. Ransomware kind of gets into your system and encrypts all the files on your hard drive and on your servers. Not cool stuff to have. So what the hackers normally do is they hold your data for ransom and they demand you give them some sort of bargain or some sort of monetary compensation for the recovery of your data. This is why backups are important. So when this does happen to you, or if it does happen to you rather, you can recover the data yourself rather than having to pay these malicious hackers to get your data back. And sometimes they don't, even if you do pay them, they don't even give you your data back. So they just encrypt your data and then take your money and run. And unfortunately, there's not much you can do about that. Software AG is a tech-based giant in Germany. So someone like them, you kind of expect not to fall for those kind of things. But I'm not exactly sure how it got in. But they do have 5,000 employees worldwide. And the hackers did ask for $23 million, which is quite a lot. Onto Cloudflare. They now send DDoS alerts. That's what it is. All right, so let's go ahead and head over to nothingness for the main talk. So take it away.
So, hey everybody, cool. So my name is Jonathan Singer, aka Nothingness, and this is Hardware Hacking Made Easy, presented to Hack at UCF on October 9th, 2020. Cool. So let's see. I've never used this feature before, but hopefully its integration with PowerPoint works really well. Hey, it works. Cool. So the agenda for today's talk is what we're going to do is we're going to talk about who am I? We'll talk about badge life, because what's hardware without badges? Like, that's one of the cool things that cybersecurity has outside of hacking itself. And then I'm actually going to talk about what is a circuit board? Like, what goes into making circuit boards, and how you can also make circuit boards and participate in all of the fun things in stuff like prototyping, about the software and the hardware that goes into this, and parts, and what boards are made of, and manufacturing, and like there's just so many different components. We're talking about reading documentation and understanding how to put all these components together. We'll cover a little bit about fabrication and assembly, and then we'll talk about the cool stuff, which is programming, so firmware, and getting your code and your software onto these embedded chips. And we'll talk about like hacking, like, so how do we hack other people's hardware? How do we break into stuff, right? And so, thank you. So, who am I, right? I have a Master's of the Cybers from USF, not Go Bulls, because I did go to UCF. I got my Bachelor's of IT and I affiliate with UCF. I don't even have a student ID from USF, so I don't care about them other than the piece of paper that they gave me. I am a DEF CON security goon, so for those that hopefully can make it out to DEF CON one day, or we're at the virtual DEF CON this year, I run around in a red shirt and I yell at people, but it's for your own fun, safety, and I hope you have fun. Over here in Tampa, I co-lead the OWASP chapter, but I also used to actually co-lead the Orlando chapter when I was resident in Orlando. I am also a co-founder of B-Sides Orlando, so thank you for pimping that, because that's coming up very soon, in about a month from now. So we hope to see everybody participating in our online virtual event and playing in the CTF if you are looking to learn something new, because that is hosted by Hack UCF. So my day job, I work at this company called GuidePoint Security, and I do Splunk for them. I do a lot of Splunk. So if anybody ever has any questions about the concept of centralized logging, RFCs, and SIMs, I'm always down to talk about it. I got lots of certs. I got like a wall full of certs over there. Like I do certs, they're cool. But I think most importantly, I am the Hack UCF founder. So hey everybody, back in the day, this was just a twinkle in my eye with Dr. Tom. And look at it now, thanks to all of the wonderful people that were there back in 2012 to help get this off the ground. So we're gonna just jump right into it. Badge life. These are badges, these are cool, right? This is what DEF CON is really about. You know, it's not about talks, it's about the badges. And so this whole concept of badges is just these different groups coming together and putting their creativity into electronics and turning it into a circuit board work of art. And I mean, it just goes on and on and on. This is several years of badge collections. And there's a whole bunch out here. Some of them I've made, some of them from just all over the world. And they're all unique in their own special way and have all kinds of fun little features and you know, challenges built into them. And the whole point is just to, you know, to kind of take your artistic creativity and turn it into something we all love, which is computers. And for the most part, all of these are actually little embedded computers that you wear on your neck. That's battery powered. So pretty freaking awesome if you ask me. And so like there's a whole aspect of like, how do you even get started and just thinking of this kind of stuff, and what does it mean to learn about this? And I'm not going to sit here and pretend that like I just, you know, figured this out. You know, I've been doing this for a long time. I'm talking probably about 8 years now. And so what does that look like? My first badge was in 2013. It's this one right here in the top right with the 9-volt battery and the green board. That was for our first B-Sides Orlando. And I had seen this concept of digital badges before, and I was like, man, I'm smart. I can do this, right? You know, I go to UCF. So I set out on this challenge to start figuring out like how to make a circuit board and what does that mean and what goes into it, and how do I connect all of these parts together and make them function in like a cohesive manner. And that was just, it was a mind drain. It took me months and months and months and months of research just to even get my first like concept of a board together. And in the end, after thousands of dollars and hundreds of hours of research and months and months and months, almost a year of just trying to wrap my head around electrical engineering basics, and not even being like, never stepping foot in an electrical engineering course. That's not my major. I just kind of wanted to learn this stuff and figure it out. This is what I came up with. It's a board that had a little like Nokia screen. If anybody remembers like candy bar Nokia phones from way back in the day, I don't know if you're old enough, but like it's just like a little monochrome screen that just displayed images, and there was pins that you could rewrite the image in the memory to display a different picture, and that was like an open challenge to people. Anyways, I put that project down for years, and I just thought like, man, it just so much went into it that I didn't want to touch hardware again. And then years later, I kind of told myself like, let me learn some more, let me figure this out. And I ended up just kind of loving it all over again. And so for several years again, I created the B-Sides Orlando badges, and I'm sorry there isn't gonna be one because we're virtual this year, so I can't give them out to everybody, but look for them in the future. This was being a little hopeful, but we'll see where things go. But for several years, so we did this blue one up here, we did this blue one right here. There's some fun B-Sides badges that I put together. This upper one with the little grid is hackable. So it's got the USB port on the bottom that you can see, and you can reprogram what's on that little display grid. This is actually has no smarts. It's all analog. That means it's basically transistors, resistors, and capacitors, basic electronic components that actually perform a function. So it's like you're doing it without any smarts. There's no code in this, but it actually has a form of motion. And then I got some other stuff. So Florida Man, right? Florida Man was a project that I took on with some friends to bring people of Florida together at DEF CON, introduce students from different universities, introduce employers to the students that were hiring in the state of Florida, and to build a rich community, not just with what's going on within Hack UCF, but across the whole state. To pay for a party in a suite that's open bar, I got to find some money from somewhere, and I'm not one to shill out to sponsors. So I started making badges. This is one of the badges. This is the conch shell that is doubled as a breathalyzer. That's what that top little red thing is. And I started making little add-ons too. In fact, the little Florida add-on, you can see it's over in the middle there, right next to the little cowboy looking thing. There's a tiny little Florida. And so it was the little add-on that went with it. And then this past year, I made a weather station in a badge. And so it was a full embedded computer with a screen and a menu and Wi-Fi, and it had sensors on it, and it was connected to AWS, and it was pretty cool. And so I can talk about that later. We have a lot to cover in our slide deck for today. So as we continue on, where's this whole concept of badges even come from, right? So the history of badges at HackerCons, right, was started by Joe Grant, and he created the first digital badge for DEF CON 14. And keep in mind, we're at 28 this year? So this has been going on for quite a while, and that's the first one. It's all the way up there on the left. It was as simple as 2 little LED lights and a battery, but it was revolutionary. It was taking the concept of what we always used for conferences, where it was plastic and lanyards. Stupid, right? Why not put a computer on your neck, or even just something basic? What's a computer made of? It's made of circuit boards. It's made of parts. And so Joe Grant did that for a couple of years. He retired. He passed it on to Lost. Lost then did it for a couple of years, and he retired, and he did, some of these, like this human one over here is a circuit board, and this one right here is actually a circuit board made out of aluminum. I mean, there's so much cool stuff that they were doing. Now, more recently, Lost retired and passed it on to toy makers, and they have been making the digital badges for the past couple of years. And so they continue on the tradition, making them more revolutionary, more intricate, more challenging, maybe even adding puzzles and making it part of a grander scale, right? And so, DEF CON wasn't the only one, who thought putting circuit boards around your neck was cool. The official badgelife community was born out of this idea of I've learned how to make a circuit board before, I can do this also. And so a wonderful individual, WBM, she started to build a community, and she basically said, hey, if you make circuit boards as a hobby for different conferences like B-Sides Orlando or your local events, or even just bring them to DEF CON, I want to hear from you, because we want to help each other out, and we want to kind of feed off of each other with information and trade parts, which, by the way, obviously anything in bulk is cheaper, so if we can trade parts, it helps. And it's just kind of flourished from there. Now it's really highly sought after to be a part of badgelife, because the basic understanding is you have to have something to contribute. You have to have learned circuitry and build something yourself. So hopefully by the end of this talk, you're willing to take on that challenge and to become a circuit board maker yourself. So today, almost all major HackerCons have some kind of digital badge. And it's not just across the country, it's across the world. And I'm even seeing digital badges at non-HackerCons, more, some Linux and Unix-based conferences and other hardware industries are also taking on this concept of having digital badges. So it's really cool. And there's a lot going on with it. And so, like any good piece of hardware, we need to talk about what's the software behind this. What's the science? Where's the cool code? And so my personal favorite is called KiCad. It's the first one up there. And KiCad's absolutely free. It's open source. And it's what I use to design circuitry in. And so you can go ahead and download that anytime and kind of, take a look at it. Now, it's very complex, as all of these are, really, when you first, start. But I'm not going to leave you hanging. I'm going to get you, going on a way to have fun with this stuff. The other tool that the first software I ever learned on was called Fritzing, and it was also open source. Sadly, it's kind of gone the way of a lot of things, where it just hasn't been upkept, and the team that was originally developing it isn't really committing code anymore. It was my favorite for a long time. And often you'll, even today, one of the cool things about Fritzing was that you could digitalize what you had physically built in front of you. And so you can have it like rendered in software. And that just gave you the opportunity to really just see what, what you were working with. It just the whole idea of recreating what's on your desk in software and then doing the circuitry, it was so cool at the time. Easy EDA, 100% web-based. And this one is similar to KiCad, a lot of features, but you just don't have to download anything. And it does feature a lot of the similar capabilities, especially for a free tool. And yes, Dr. Tom, the QueerCon badge of 2016 was one of the great ones. That community over at QueerCon loves to design badges. They have some of the most talented electrical engineers I've seen. In fact, the one that Dr. Tom was mentioning was a squid that actually interacted with other squids when you connected the headers on them, and they we become friends and things like that. And so badges were now communicating with other badges. Again, there was just so much fun stuff out there. And then finally, Eagle. I can't go on without mentioning Eagle because it's one of the oldest out there. And it was kind of the standard for a long time. I just don't really care about it really because it costs money, and that's just not my jam. I like free, I like open source, and I don't do this for a living. I do this for fun. So let's talk about prototyping. Prototyping is that concept of putting your idea to life, right? And so this is usually the first step when it comes to most circuit boards. And what we're doing here is we're taking like one of these breadboards and we're placing the components on a breadboard to proof of concept our circuit. And so the way that this works is that on these breadboards, the 5 pins on the inner channels go horizontally, and then the 5 pins on the outer channels go vertically. So you can see the little plus and minus up there, and basically that is interconnected all the way through the inside. So that would be like your positive and your negative power, right? And then on the inside 5, they go in and outwards, and that's sort of connected. And so you can see here that, for instance, this resistor technically connects all the way through to this pin on this chip. And so this is like an inner channel. And then out here, these are power channels that go, again, up and down the whole board versus 5 inwards on each side. These are super cheap, they're super fun, but the whole concept is taking these through-hole parts, right, big pins as you see here, and just locking them into these little metal clips on the board. And so now that we're starting to prototype, we're putting our idea to life, right? And we're connecting pin 7 to this resistor, and pin 3 to ground, and this LED to pin 6, right? And we're basically following the recipe, right, or the diagram. And so, we're not at full circuit boards yet. This is your proof of concept. This is putting it together on these breadboards, and these are like stupid cheap. I mean, under $1 a piece. I've got a whole ton of them, buckets of these things that I've collected over the years, and you can probably get your hands on this stuff online also for super cheap, if not out of China, even domestically, like Amazon or something. So once you feel really confident in your breadboarding, let's say you want to put something a little bit more permanent. You could use something like this Perf board. And what happens is actually the bottom side of this is copper. And copper is your conductive material that you solder or you connect all these metal joints together on. And the top side is more of your presentation side and where you're making all of your jumps and putting all your components on. This isn't used as much these days. In fact, you can run something for the most part full-time in a breadboard as long as you don't accidentally pull the pins out or mess with it too much. It'll function and it'll work as expected. But I've definitely seen plenty of people build on Perf board for more of a soldered in permanent experience. But we want to build something, or we want to manufacture something, and that's what we're talking about, full on circuit boards. And so this whole time we've been focused on what we call through-hole technology, THT. And that's where the pins of a component pass through from the top to the bottom of a board. And so what does that look like exactly? That we take the component and we pass the metal pins through, and we're electrically connecting it on the bottom side using solder to the pad. And solder is nothing more than essentially heated liquid metal. And that gives us the opportunity to bond the pin to the connection on the board, these copper traces here in red. And that's really, you know, the basics of how you put together a component into a circuit board, right? And so when you have your random circuit board of choice, you have to keep in mind that you need to electrically connect things. Just by simply placing it is not the same as like the breadboard, which is essentially a little teeth in there. This actually still needs to be heated up, soldered, and you need to ensure that there's good connectivity for the components to connect and to pass their signal through. Now, once we kind of graduate past through-hole technology, we start to get into what's called surface mount, or SMT, surface mount technology. And surface mount, similarly to a through-hole, is the same chips, right? It's capacitors and resistors and these integrated circuits like this. But the big difference is instead of passing through for the pin, it sits on a side, so either top or bottom, right? And so I have a small, you know, SMD surface mount technology. So like this is an example of a little surface mount board. And you can see here, all of the components are just simply sitting on the top of the board. The bottom, empty. It's plain, it's just green with some writing on it. And so all the little pieces are sitting on top and mounted on top. And this was revolutionary. I mean, we took components that were, you know, about a ½ inch long, and we're shrinking them down to just a couple of millimeters. And that is awesome. It's fantastic because now we were able to shrink and we're able to compact things. And so suddenly our space required to put together these circuit boards is so much smaller. I mean, literally, this is this whole circuit board. What if I told you that this device I'm holding here with this wire was like a full wireless computer? Like, that's what is capable with surface mount versus having something that's all through hole, like this kind of device, where you have to have big components like these capacitors and these little jumper headers here, and we can see that they're all soldered and all the pins stick through the board. And so now that we're getting into surface mount technology, which is what I do most of my boards in today, we're really, you know, kind of taking a step on things. Now, circuit boards do not have to be green. Like, not all boards are green. If you build computers for fun and you've seen motherboards of other colors, you can make them in a variety of colors. Now, green is actually the preferred color because of the way that it reflects and the way that you can see minute details on it. It actually allows people to inspect in a clearer and easier method. So that's why things are green. But it's as simple as just simply asking your board manufacturer, hey, I want it in blue or white or black, or actually you can make custom colors because it's simply just paint. And so that's the top, right? And that's what we call our, you know, our solder mask. What's really going on underneath that paint, right, is it's a straight sheet of copper. And we etch and we remove, and that's where we ultimately end up with our circuit. And so what's going on underneath all of that green paint is actually all of these little metal traces connecting all of the different components. And so now we're starting to move through. So the top one is what our, you know, what we see, maybe that color and maybe some exposed pads to solder to, right? Those metal points, but you can see kind of, they look like shadows almost as the metal underneath that paint. And that's what this is those are all those traces, because you don't necessarily solder to all of that. You only solder to where the component joins the board. You don't necessarily solder to this tiny little thin trace wire here. But this is what it starts out as before. It's just a straight sheet of copper, and you use an acid wash. It's almost like a film exposure, think of, to eat away at the useless parts and leave only the traces required for your circuit, okay? And boards aren't just a top and a bottom necessarily. Like, you can have copper layers on the inside and in the middle. And in fact, if you research, I believe the modern iPhone motherboard has, I think, 18 layers or something crazy like that inside the board. And so you can have these copper traces flowing in other directions, sandwiched in between the board to make connections to places that maybe are interrupted, right? You don't want, if a trace hits another trace, it's either going to electrically connect or you need to figure out how to go around it somehow. So if you have other channels and other means of getting to, your components on the other side of the board, you need to consider going through maybe the inside. And so how do we do that? Well, we can use these things called vias. And via is the way of getting a signal from the top to the bottom or any layer in between. For instance, a via can be between two of the inner layers. It can go from a top to one of the inner layers, but not the rest of the board. And so vias allow us to take a trap. So let's say I need to have a signal that's coming and I have another signal here. I can go under through a via to another layer and then pop back up to a via. And so that's how we avoid electrically connecting two paths or two traces so that we don't accidentally short something out, but that at least gets us a signal from one side of the board to another. Now, that's the basics of circuit boards. Let's take a look at what this software actually does for us. And this is what I was talking about, how we take that breadboard down that we've learned about breadboards, and you can actually put all the components in a virtual breadboard and electrically connect them the same way you're doing it here on your desk. And that's so cool because then you actually get to see how things are all connected, and you get to kind of like share like a graphic image, not just a picture, but you can actually see it here. And so again, I miss the software. I wish they would start developing it again. EagleCAD is another one of the big ones, right? I mentioned earlier, and this is pretty much an industry standard for commercial. There's also like a whole nother tier of commercial software, like Altium is one out there that is just expensive, but it's got so many great features and so much great support for building circuit boards. But we'll get into how we even get to this phase here in a second. But I think the first trick of any circuit board is how do you, bring it all together and make it functional. And it starts, in my opinion, with schematics. And schematics is like that visual documentation of what connects to what and how. So what's going on in the schematic here, for instance, is each one of these green lines is essentially a trace. And then each one of these giant rectangles is a microchip. And then each one of these smaller parts, they're little passive components like a resistor or a capacitor or a transistor. And this is how everything ultimately connects. This is how it's all networked together. And so schematics are like your documentation or your publications on how your circuit actually works. And so you can go online and find schematics for almost anything these days. And this gives you the opportunity to recreate it and put kind of maybe like certain components or parts of this schematic into yours board because you find this functional and it works. And maybe even the developer of this chip gives you schematics and they say, this is how you make this chip work. And this is all you have to work off is a schematic. So you need to be able to kind of start to figure out what some of this means. Now, we're not going to get too detailed, but, this is a chip and this is a resistor and that's a power source. But really, how do we make sense of all of this? Well, we start out with the chips themselves, right? And we read the documentation. And so a standard microchip may have, a ton of different pins all around it. And so you can see here the chip in the middle I have on my camera has pins all around the outside. And so we have to start by understanding, well, what does each of those pins actually do, right? And so according to the documentation, AKA read the manual, this explains what each of these pins actually means. And again, we can dig deeper into what all this means. It's not just going to show you a picture of pin, and you count in order around it and stuff like that. But they'll even go into further explain, okay, PC0, also known as ADCO, means this, and it's a whole other section of the documentation. So the first step is understand what you're working with and what each of these pins functionally does. After that, this is when we really get into the schematic stuff. And so components in schematics are standardized. This is just well-documented stuff. And so I have this table here of all different types of symbols that were used on that schematic. And this is how you actually read this stuff and determine what all of these different pieces really are. And so we have stuff like resistors and capacitors and diodes and switches and transistors, or even, like I mentioned, these rectangles, which are the integrated circuits, AKA microchips. And so now that we can read a schematic and we understand the purpose of the pins on our integrated circuits, like here's pin 19, which is PV5, also known as SCK, right? We have a book that can explain it, and we have a reference guide so that we understand the illustrations. Let's start to put all this stuff together. And we build our schematic, and finally we get to the moment where we say, okay, now I need to build a circuit board, right? But how do we build a circuit board? How do we decide where to put all of these different components, right? And that's like the next fun challenge, right? And so I have a board up here, and I believe, I don't know if we have the ability, but yeah, I believe people can unmute themselves as they want. But does anybody, can anybody guess if they want to type in chat or unmute themselves? Take a guess at what this board actually is. Boom, Nicholas, you are absolutely correct. This is an Arduino, right? But this is what an Arduino looks like in like CAD software, computer aided drafting circuit board software. So Nicholas Gray, you are absolutely correct, and you win 7 internets. So, but yes, and so what's going on here is you have these red traces. So red is on the bottom of the board, and you have these blue traces, and blue's on the top of the board. And so, and then green are where the through-hole components connect and get soldered on, and the red like the red looking pads, that's where like the surface mount components go. Because you can see the green ones, they have a hole drilled in the middle of them. Right, you got to go from, go through the board so that the pin can actually go through the board and get soldered and connected. And so Arduinos are a mix of surface mount and through-hole technology. And oftentimes you will find a lot of boards that are just a mix of 2 components. It may be coming down to price. It may be coming down to certain things being removable versus things a little bit more permanent. But again, very, very good guess there. If you have an Arduino, great. If you don't, Nick, reach out to me. Maybe I can work on getting you on. So, so how do we even get to the board? Well, we get to the board. We've started to consider how do we lay out. But really, at the end of the day, what does this all mean? Like, am I just going to print this out on my printer? Am I going, am I going to 3D print this? Am I going to laser print it? Like, I don't understand. How do I go from a piece of software where I'm putting all these connections together to an actual physical board? And the output, or the distributable, like the publishable component of circuit board design, is called a Gerber file. And a Gerber file is a combination of all of these different layers put together. And so a Gerber file will have the traces on the top of the board, the traces on the bottom of the board, where to drill all the files, where all of the chips go, where all the writing and the little text on your circuit board is. And so Gerber files is a culmination. It's almost like an archive of all of these different graphical layers and key pieces of your final circuit board project, right? And so drill files in your Gerbers physically tell a robot controlled drill size 1 here and size 2 here, right? And drill. And that's how you prepare for through-hole components. Copper layers are what get exposed. Like we saw earlier, you have a fresh sheet of copper, and we put down this negative, and we expose it with ultraviolet light and other kinds of acid washes to the point that what's not hidden behind the negative gets eaten away, and these black traces are basically all that's left over. It's kind of like how you make photography. It's very similar in that sense. And so we expose it with chemicals, and we hide what we want to keep, and we leave what we want the acid to eat away at, and that's how we get our traces left over. So now that we're understanding what's required to send to our manufacturers and what to share with them, and what, just kind of for our own reference, what this looks like, optimize your manufacturing, right? If these boards are small, a panel is what a copper panel is what these circuit boards start out as. And so they're giant sheets. And so you can put a bunch of your components arrayed or spread across these panels, and we call it panelization. And it's the best way to kind of optimize your space and to get the most, because for instance, most manufacturers charge by the panel. And so if I say I only want 2 of these things and it's a small corner of the panel and you have the rest of this that's going to waste, well, you're paying for the panel. Populate it, fill it up. And you'll find sometimes that you'll get 10 for the price of 1 because that's just how many it took to fill up the panel. And so it's great for just considerations when you're getting into manufacturing. There's a lot of companies out there that they'll sit here and they'll tell you, oh, you get 1 or 2 of them and it's like really expensive. Like, no, what are you doing with the rest of that panel, man? Just panelize it and give me the whole thing. And we'll get into how companies work at that stage. But just things to consider as you're starting to go through your steps of design and layout and ultimately shipping off your files to be created into something real, right? Something tangible. Things to consider, how this all works, right? Is I talked very high level just initially about that green layer, but what it is, it's called solder mask, and it's a coating, right? It's like a paint, it's like an enamel, and it's meant to cover up the copper for areas that don't need to be exposed, right? And to only allow the exposed pads to come through. And so you can see the solder mask is protecting that trace, but it's exposing these pads because that's where you're supposed to put your components and adhere them, electrically connect them to the board. And obviously, it's taking mention of some of the other stuff, but the idea is that you want to protect the copper layer of the board from damage or accidental. Imagine if you just had the exposed metal and you accidentally touch something, you can get hurt, or if metal touches metal, you can short circuit something. So it's great to have a protective layer between what's meant to be exposed and what's electrically going on underneath. So the PCB manufacturing process is huge, and I'm not going to go into full detail of this. I implore you to go on YouTube and watch a cool video on how PCB manufacturing is done. But the idea is it's all of these different robots starting from that initial board. You can see that first board cutting edge. It does all the drilling and the chemicals and the exposing and the etching, and then there's a computer vision, and it looks at all the parts to validate that it matches what the software originally did, and then they clean it, and then they etch it again, and then they put on the solder mask, which is that green layer. Again, it can be any color you want. And then ultimately, they can, finally at the end of this, you have a really pretty nice board that has been tested and is functional. Because they have these like little touch pins that go on and they say, okay, this is supposed to connect to this. Does it work? Yes. This is supposed to connect to this. Does it work? Yes. So check out the YouTube video. It's super cool. Just go on YouTube, PCB manufacturing. There's a ton of them. Just factory tours are so cool. And so what do these machines look like? They're huge. The fabrication machines are awesome. And the boards like kind of just go through on a conveyor belt and they do whatever they do with the chemicals and do whatever they do with the drills. And it's pretty fun stuff. The other fun thing about manufacturing is assembly. And so we haven't talked about assembly yet, right? I've been telling you that you need to solder all these parts, but this is what we call pick and place. And this is one of the, I would say, most rewarding things to kind of just watch on YouTube, is just watch the robot pick up the part from these little ribbon here in the front. They're like little spools. They kind of look like this, like a spool of components that are on a reel. And it picks one up and it puts it on the board. It picks one up and it puts it on the board. And prior to this step, it added a little bit of solder so that it can place it on the solder and it'll actually like heat it up as part of the process. And so after manufacturing or after the fabrication, which is the making of the board, and you get just a blank green thing, if you want it assembled, you need to put it through another set of robots. And so what we'll do here is we'll take the solder paste, which is it's like a paste of liquid metal balls, essentially. And we paint it on all these little pads where all the components go, all those little exposed pads. And then we have the robot mount them. Again, watch YouTube video, super awesome. And then we put it through an oven. And that oven heats up to like 300 degrees Celsius. And it melts the metal. And through surface tension, it adheres all the parts exactly where they need to go. And then finally it pops out a little board. And so parts come in different varieties, right? You can get tubes. And so, sometimes if you just have like a big through-hole microchip, it comes in a tube like this. Now, when you start to get into this more surface mount stuff, you get like that reel, like I showed you in a second ago. Reels actually can be cut down into like smaller strips like this. So there's about 5,000 resistors in that reel. Most people don't need 5,000. They maybe need like 20. And so most places that you buy parts from, they'll cut you off smaller segments too. And just in general, a lot of these parts can be done in reels, can be done in tubes. There's all kinds of different ways of the robots either picking up the parts or at least them getting to you, and then you can kind of pick them out and build it yourself. And so when a reel is in a pick and place machine, it feeds along like a little track belt, and there's a little tiny little vacuum nozzle with a camera, and it goes over and it drops right down and it picks it up with a vacuum, and then it looks over a camera to verify that it got the right piece, and then it brings it over to the board and it places it exactly in the right rotation that it needs to be in. Similarly for tubes, it kind of like it shimmies them along and it picks it up with a vacuum and it places it in, or you can hand place these things yourself too. If your chips are pretty large but they're surface mount, you can get them in a tray like this, and again the robot will fly over to it, pick it up, and place it on the board. Watch the YouTube videos, pick and place machines, so cool. So not everything can be done by a robot. Oftentimes there's still going to be just a handful of components that need to be done by hand, which is fine. A lot of manufacturing places will do hand-built assembly for you. I personally opt out of it. I do it all by hand myself because people cost money and there's a massive labor charge. So just kind of something to keep in mind. But these manufacturers will do every entire aspect for you, turnkey, what we'll call it, which is, you give them the Gerbers, which is the designs, and they'll take care of everything. They'll source all the parts, they'll put it all together, they'll test it all, and they'll mail you back a fully functioning assembled working board. They'll even program it for you. So what happens is when you put the through-hole components on, the board actually like skims over a liquid metal solder bath like that. So that's 300 degrees Celsius, just bubbling and like floating there. And what happens is the board just basically like just skims across it and automatically solders all of those pins on whichever side hits the bath. It's pretty cool. Again, there's awesome videos out there. I don't need to show you how it works because you're going to spend all night watching pick and place videos, I guarantee it. So let's talk about how to program them. So when you have smarts, when you have little integrated circuit chips that are programmable with code or serve a function, we need to consider the tools, right? What's our tool chain for getting data onto these things? So one of the most popular ones, and we mentioned this earlier, was the Arduino. And so Arduino has a piece of software that you can write C code in and then electrically connect it using some either USB port or wires, and you connect it to your computer, and it compiles the C code and it boom, puts it on this microchip. And it gives you the opportunity to now run some functions. So this particular board that I have here, this Arduino on it, this is a CNC controller. So it controls motors to determine the position of a drill to make a pattern. Look it up, super cool. Atmel Studio is another one. They're the manufacturer of this chip. I don't use it, I like Arduino. MicroPython is cool. Did you know that you can run Python on a circuit board? So if you're really good at Python, you can find circuit boards that are built around Python so that you can program your own code. So you don't have to do it in C, but you can still blink a light and other things too. I nowadays use VS Code. I hope a lot of people that are programming use VS Code because it's a solid platform. But within VS Code, there's something called Platform IO. And it's basically the new Arduino platform these days. Check it out, highly suggest it. It's not, I wouldn't say it's compiled. I think it's just in time. But just look it up, MicroPython. I don't do much in it. I've touched it like once or twice. I do most of my stuff in VS Code and C still, which is, again, like I mentioned, Arduino 2.0. Or, if you guys are doing Java and you like Eclipse, you can adapt Eclipse to do Arduino code too. Because all of these IDEs are now pretty much cross-compatible these days. So you already have like at least one of these if you're doing any kind of programming, unless you're a true, Notepad++ warrior. So let's talk about how we get the data on there. And so we use something like an adapter board, right? And so I have one right here. This right here is called an FTDI. It is the chip up there in red. But all it is it's a serial converter. And for those that don't know what serial means, serial is like something like RS-232. It's essentially a language or a protocol that your computer is going to speak to transmit data in a serial versus parallel fashion. And again, I don't want to get down theory here, but oftentimes you may need some kind of adapter or programmer for your board to hook it to USB. Like luckily this one has USB on it, so I can program it away. Other boards, I have to use this to convert USB to serial so that I end up soldering these pins. In fact, I was just working on this the other day. This little Wi-Fi computer that I mentioned earlier, I actually had these wires soldered to this, and I was using this board to program the code on this little guy. So you're gonna need some kind of adapter if the functionality is just not, a lot of the chips these days have USB built in and are capable of being programmed directly. Other ones you just have to have some kind of serial converter, some kind of adapter to speak the language, right? Now, let's talk about the supply chain. Where the heck do you get this stuff from? China. Sorry, you get everything from China. It's all manufactured there. It's just how it kind of works. It's where I get most of my stuff from. The thing that, like, here's the reality of it. It's a fraction of the cost than things domestically. And right now in my life, you know, the operating cost, when it's 10 times cheaper in China, that's kind of where I'm going with things. So whether you like it or not, even if you buy a microchip here in America, it was manufactured in China and initially sold in China. So it just takes a little bit longer. The joys of international shipping, if anybody's ever bought anything from AliExpress or accidentally stumbled on something on eBay that was from China and it took 60 days to get here. I have better methods of getting things here quickly from China. I'm talking like 48 hours. If you are looking for parts, let me know. And it's always fun negotiating for a 1,000 of a component. I need 1,000 of these microchips, and like you know, you gotta have like it's fun. Baidu English translation is not exactly the best, but yes, there are wonderful places here in the States that you can get all the parts you need. But I buy everything overseas, and I also get all of my services done overseas. My part suppliers, I like LCSC. It's a fantastic company, and they have pretty much almost everything, and it's super cheap, and they're just really helpful. AliExpress is the eBay of China. I'm not telling you to just go out and mess on AliExpress, but it's also where I get a lot of cheap parts very often. If you want to get things domestically, Mouser and DigiKey are the other, you know, standard go-tos. I definitely buy stuff from them still if I need it quickly or if I need it a very specific thing that I can't find and I just know they have it. I also use them sometimes as a backup supplier, so nothing wrong with it. I have accounts with both of them, and I buy stuff from them all the time too. Let's talk about microcontrollers. So, right, these smarts, these chips specifically that you're going to go out and get from those suppliers. There's a lot of different manufacturers out there, and they all kind of do a little bit of a different thing. So, if anybody's familiar in Engineering 2, downstairs in the TI lab, Texas Instruments, they will I think they'll still give, I don't know if they give them to you anymore, but they used to hand out free MSP430 development boards. Like they would give you the TI version of an Arduino for free. So I don't know if that's a thing anymore, but if it is, go get one. They're cool. But TI is one of the big ones. They make the MSP430. It's a great development board. It's very similar to Arduino as far as functionality goes and the coding goes. Microchip is actually literally the name of the company. It's called Microchip. They make the PICs. Atmel is the one I'm mostly familiar with. They make the Atmega, which is your Arduino that we all know and love. SI, Silicon Labs, is coming up. They make a really cool stuff. They make stuff called the Gecko. So they make some great chips. NXP is super advanced, but they make great microcontrollers. ST Micro is who I actually use most of today. So it's called STM. And STM32, I think, is probably one of the most popular Arduino and like development board kit or chip like manufacturers today. So I use a lot of ST Micro. There's Freescale, there's Espressif, there's all these different ones out there. But I'd say most of the ones I stick to are TI, Atmel. Microchip's a little bit older. PICs were what people used back in the day. And then STM and Espressif. Espressif is the new up-and-coming one. That little tiny board I showed you that's Wi-Fi capable is an Espressif. So, but again, for the most part, all of these in some way or another support Arduino, which is great. So Fab Houses, let's talk about companies that make boards. Like, who do I give those Gerber files to, right? I send them from our board software. Oshpark's cool. They make purple PCBs. They're very popular in Twitter and the social space. They're domestic and they're fairly cheap, quick turnaround, but they have kind of a cult following. It's kind of fun. But like I said, the boards are all purple. Macrofab is also US based, and they make a handful of the badges for some of the badge teams in badgelife and at DEF CON. And then you start to get into the Chinese manufacturers. So I've used all of the ones, the four listed here. So Elecro and Seed Studio, I've used a little bit here and there when I need something that comes down to like a price thing. But bar none, JLC PCB is who I do all of my prototyping through. So if I need like 10 of a board to make sure it works, that's who I get them all from. JLC PCB, it's literally like, I think it's like $2 for 10 boards, and then you just pay shipping. PCBWay is my mass production company. PCBWay is who I get 1,000 boards from that are all pick and place robot assembled. They do all of that in-house, and that's who I go through. And again, if anybody's like getting into this and starting out, please reach out to me on Discord, and I am more than willing to share my contacts, discounts, and how to go through some of this. They also speak great English. So distribution, now that I've made boards, now that I've gotten back from my manufacturer, like, can I make money doing this? Can I make it more than a hobby? And the answer is yes. Tindy is a great outlet for selling your wares. It's owned by Hackaday, if anybody checks that out, which is a hardware blog. Crowd Supply is another one, very similar to something like Kickstarter and Indiegogo, where, you know, I think what's the big one right now is the little flipper dolphin, right? Somebody put some cool stuff, some cool code on a circuit board, and they're selling it, and they're making a ton of money. And finally, taking your wares to conferences. Like, so when I go to DEF CON, I always bring my badges with me, because people love them, and I need to throw a huge flow demand party, and it costs money. So buy badges, right? Okay. I talked a lot about manufacturing, and I talked a lot about making this stuff. Let's actually talk about hacking hardware, like digging into things and screwing up other people's stuff, right? And so hardware hacking, the whole concept of hardware hacking is getting into other people's computers, right? Into their hardware, into their mini computers. And so like I posted up some really cool tools here. I do not have a JTagulator because they are very expensive. It is pink. Remember I told you can make them in any color you want. But a JTagulator is a way of interfacing with a microchip on a board using what's called the JTag interface. It's a standardized kind of interaction and communication channel with a lot of chip manufacturers for like debugging purposes. And a JTagulator allows you to connect to that debugging port and kind of mess with the chip and maybe read its memory and stuff like that. I do have one of these in red. It's called a Bus Pirate. And I've used it multiple times for reading data channels and watching a microchip communicate with another microchip on a circuit board, and then like intercepting that data and then kind of flooding it with my own. And so it's really cool. And that's a lot more cost effective. And then this little thing up here is kind of like it's like a probe set, and it allows you to like kind of spectrum analyze and watch what all of the different pins are doing. And so how do we even get started in hardware hacking? Well, let's think about mini computers that we already have around us, right? A smart TV is a mini computer. A modem and a router is a mini computer. Your LED light controller that's Wi-Fi is a mini computer. And you have to ask yourself, well, they programmed the mini computer somehow, some way initially from the factory. Maybe I can figure out how they programmed it. And so the trick is to look at the board, and to not just look at the board, look at the board objectively and look for programming headers, right? Series of pins in a row, okay? And this gives us the opportunity to start to figure out, okay, Well, I understand the components used here, and according to the documentation on that TI chip over there, that ARM Cortex processor with the little Texas symbol on it, that chip supports JTAG. Well, that means JTAG's got to be around on this board somewhere, or it supports serial. It's got to be around on this board somewhere. And so you start to look at the pin headers, and boom, there's 2 pin headers that were identified on that board. Got it somehow. We got to talk to it. So we use those hardware hacking tools, and we solder or connect directly to these programming headers to start to read. And so RX and TX stands for receive and transmit. That's a serial communication standard to interact with this board. And so now that we're starting to identify and find ways of communicating with our commercial hardware that we want to hack, we have to figure out how to really communicate with it and get in there. And so sometimes that may require dumping the memory of a microchip, or it may require using one of those serial converters to communicate directly with it. And so this little modem here, it's running some kind of software, and we need to figure out what's on it. Maybe we can, if it's running a tiny version of Linux, we want to get root on it and maybe change the firmware so that we can increase our modem speeds. A little bit illegal, but it's what people used to do back in the day. And so just taking on these hardware hacking challenges, it just takes a little bit of investigation and reading and understanding what people how it came out of the factory, and that so this is how the original Xbox was hacked. Somebody identified 10 pins on the motherboard that were a JTAG header, and they connected a JTAG device to their computer to communicate with the Xbox motherboard, and they're able to directly interface with the microchips and bypass all kinds of security. Like, this is how hardware hacking is made, is by identifying opportunities to get into the data and get into the software running on these chips, that was left behind by the manufacturer. So there's always a way in, guarantee it. Then you compile that with some kind of software suite, right? And so this is an example of something called the ESP8266 flash dumper, AKA pull the firmware off of that little tiny wireless chip that I was just showing you. So this little guy, I can pull all of the compiled code with this piece of software right here. I hook it up to the serial pins on the back, and I run the code, or run the software, and it pulls down all the compiled code, all the memory off the chip. And that gives me an opportunity to reverse engineer it, right? And we all love reverse engineering because it's hard. But nowadays, we've got stuff like Ghidra, and Ghidra is like reverse engineering for like noobs. And I don't know how to reverse engineer, but I do know how to use Ghidra, and I can decompile all kinds of cool stuff with it. And so I dump my firmware into these tools, and I start to see what was the original manufacturer setting out to do with this, or furthermore, can I find bugs in it, right? Can I hack this system? So it's my challenge to all of you. Have fun with it. Now, it's not all perfect, it's not all gravy. A lot of these manufacturers are now designing all kinds of security things. For instance, preventing the readout of memory, or preventing, even if you get at that chip and desolder it and pull it, all this kind of stuff like that. They're stopping us, right? But we'll find a way, right? It's not everything. Now, before I get to the fun stuff, I wanted to leave everybody with a couple of resources. Now, when I mentioned I started doing this back in 2013, I watched a lot of YouTube. YouTube University, I think, is the best university out there for learning anything new. And some of the channels that I am really into when it comes to learning how circuit board design, circuit board electronics, electrical engineering, all this kind of stuff works, these are the people. And so contextual electronics is awesome. That's where you can learn KiCad. Wonderful, wonderful, wonderful tutorials on how to build anything. So check that out to learn the software. EEV blog is where I learned how to do board manufacturing, and Voltlog, Julian Elliott, BigClive.com, Marco Reps, and Great Scott. I mean, these are the people that just talk about and show you how to just design circuits and design everything in schematics and manufacturing and putting it all together and building just really cool projects. So along with this talk being recorded, I will be sure to share out these slides so that you also have access to this. But these are the people I watch on YouTube to learn everything you've seen in this talk. And yes, Zach, EEV blog is the best Australian ever. So, do we have any questions? Because this is it. This is the end of my talk. You know, throw them up in the chat, or shout them out over your mic, or anything along those lines. I know we covered a lot, but do not be intimidated. You know, just YouTube University, have fun with it, and I'm here if you have any questions, whether now or over on Discord. So, silence is bliss. I'll take that. Plus, you probably want to know what happened with your elections. So, all right, well, we'll call it. Again, reach out, say hey. Oh, do you have any pics of more cool badges? I do. They're over here somewhere in my office. I didn't bring them out necessarily, but I am working on some other fun projects. Like right now on my desk is this. It's a mini CNC and laser engraver using this little controller board, and so I'm building this up, and it's going to have like little motors that track back and forth. So that's one of the projects I'm working on right now. Another project I'm working on right now is to hack this flight controller. So this is the radio remote control for like an airplane, a model airplane or a drone. And it has a certain chip in here that I'm going to solder my little USB programmer to, and I'm going to rewrite the firmware on it. And so that's one of my projects that I'm working on. And that little wireless board that I've been talking about this whole time is actually connected to this spool of LED lights. So this is RGB lights that you adhere and hang up anywhere. And so this I'm reflashing with either ESP Home or Tasmota to hook up to my soon home automation system. So I'm gonna have voice controlled lights. So software's everywhere and hardware's everywhere. And so I really enjoy this stuff and having fun with it. And hopefully everybody learns something new or wants to take on the challenge of breaking something open and figuring out how it works. So at this point, I'll just go ahead and throw it back to you, Michael.
All right. Thank you, John, for that presentation and taking the time out of your day to come talk to us all. It was a great talk. Virtual applause. Let me go ahead and share my screen and we'll move on to the election results. Yay. And now you can see me. All right. So the election did close at 6:30 automatically. So I'll load the results on the other monitor and kind of read them off as they come. So there are 20 votes total. And Jeffrey DeVincent received 20 votes, which is 100% of those that voted, which means that Jeffrey is going to be the next secretary for Hack UCF. Another virtual applause. Yay. All right. So with that, we're going to end close this out. Once again, thank you, John, for coming out to speak to us. We appreciate it, taking the time out of your day. And thank you, everyone, for attending this meeting. Everyone's welcome to hang out in our Discord in that virtual Cyberlab that we have. And we also do have that workshop tomorrow at noon. That is Saturday. And we hope to see some of you there. So I'll go ahead and call this meeting here. Thank you again for everyone for coming, and we hope to see you next week. Have a good one.